Hello students, this is the sixth lecture of this video series, and this is actually this would be the sixth lecture as well as the last lecture of second unit. So I'll try to complete everything which is in your syllabus in the second unit. Apart from this, this is all about input output programming, port programming. This won't be a large video, it would be a short video. Apart from this, I'll share a document with you which will be consisting of all the various example programs which would be useful for you people, and that would be useful for your semester exams also. Fine. So I advise all of you to please go through those programs, and if you have any doubts in those programs you can clarify on the WhatsApp group. Fine. So let us start the unit. This is the input output port programming. Fine. So we all know we have 4 ports in 8051. Initially we have studied. Let us go again towards the IC of 8051. 8051 consists of 4 ports: P0, P1, P2 and P3, and all the 4 ports are of 8-bit. What does it mean? It means that all the 4 ports are having 8 bits: first bit, second bit, third bit, fourth bit, like this. Fine. You can identify from its name also. Fine. For example, you have 4 ports: ports P0, port P1, port P2, port P3. Fine. What are these ports and why they are used? These ports are actually those students who have already studied the microprocessor would be knowing that we are having 2 kinds of buses in a microprocessor. Those are address bus and data bus. Even mechanical and civil students should know this, that every processor has 2 kinds of buses: address bus and data bus. Address bus, which carries the address from the microprocessor towards the memory, and data bus are bidirectional buses which carry data from the microprocessor towards the other units, and from the other units towards the microprocessor. Fine. So you have two buses. But in the microprocessor, what happens, the data bus is of only 8 bytes or 16 bytes or 32 bytes. Fine. So you just have a single data bus. Using that single data bus, you can communicate to other unit only one at a time, only one unit at a time. Fine. Are you getting me? If you have a microprocessor something like this, or a microcontroller, you can take anything. If you have a microprocessor or microcontroller something like this, then you have a data bus and you have a address bus. This is of either 16-bit, 32-bit or 8-bit. Fine. So let us say it's a 16-bit data bus. Then using this data bus, you can interchange the data, or you can exchange the data from the microcontroller and a unit. Any unit can be a any input unit like keyboard, and any output unit like monitor, or n number of units there that are attached to microcontroller. Fine. So you can exchange data between them. Fine. But what you can do, if you wanted to exchange the data between n number of units, so what will happen? It will exchange the data using the same bus here also, same bus here also, and same bus here also. You cannot communicate at the same time between 3 units. So what you do, for the first second you will communicate with this, for the second time unit you will communicate with this, at the third time unit you will communicate to this. If your work with first unit is yet not complete, so you will come back again to this first unit and do your work, and then to this unit. So you need to kind of switch between the units. For example, you have to do time division multiplexing. Fine. You have to divide time and give time to all the units while exchanging data between the microcontroller and the units. This is how the work take place in a microprocessor. But what is the provision which is given in the 8051, or other microcontrollers also have this provision, that instead of a single data bus you have 4 data buses. Although the name is not data bus, the name is ports. The name are ports, but they carry the data. Fine. You remember this thing. The name is not port, name is not data bus. We are not calling them data buses here. but indirectly they are working as a data bus. They carry data from one port, from the microprocessor or microcontroller towards a unit, and from a unit towards the microcontroller. What is the size of data? 8-bit. So at a time they carry 8-bit data from the microcontroller to a unit and from a unit to the microcontroller. Fine. And our original problem was that at a time a microprocessor can communicate only from a single data bus to a single unit at a time, but 8051 can communicate up to 4 different units at a time, because it has 4 ports. Fine. So it's kind of, you can say, you have 4 different data buses, 4 independent data buses in 8051. Fine, try to remember it like this. But technically they are not data buses, they are known as ports. Fine, they are known as ports. Ports P0, P1, P2 and P3 all are 8 bits, and they can independently communicate to any unit, and they are bidirectional. Data can go from the microcontroller towards the unit and from different units towards the microcontroller. So these are used to exchange the data. So what we'll do, we will see all the ports one by one and how to use these ports in the programming part. Fine. So this is important. Let us go port by port. Initially, when you reset your microcontroller, or when you turn on your microcontroller, you can also say like that. When you turn on your microcontroller, all the ports are designated as input ports. So what happens, you have to define whether you want to use your port as input port, whether you want to, for example, P0, you have to define before programming, you have to define before exchanging data between any unit and 8051, you have to define whether you wanted to use that particular port as input port or output port. Fine, you have to define. So when you turn on your microcontroller for the first time, when you power it, give VCC, power it, then all the 4 ports are designed or designated as input ports. Fine, when it turns on. But what if we wanted to use these ports as output ports? In that case, what we have to do, we have to write a value 1. We have to write a value 1 to these ports. We have to write the value 1 to these ports. And if whenever we write 1 to these ports are configured as output ports. Fine. Or otherwise they would be configured as a input port. Fine. So what does it mean? It simply means that you have the ports P0, P1, P2 and P3, 4 ports. Now if you wanted to configure these ports as input port, what do you have to do? You have to write 0 on these ports. Fine, you have to write 0 on these ports. In that case, all the ports will be configured as input port. Fine. And if you wanted to configure them as output, if you wanted to use them as output ports from the microcontroller, which can take data from microcontroller to different units, then you have to write 1 on them. This is the first thing. These are not datas. What are these? These are just the flags. These are just kind of flags to configure the ports. Fine. So by what we are doing, we are sending data 1 to port 1, and now what will happen? Port P0 will now start acting as a output port. Fine. If you write 0 on this port, then port P0 will start acting as a input port. Then, for example, if you have your 8051 like this is your port P0. From the 8051, using the programming, you write 0 on this. Now your port P0 is configured as input port. Now port P0 will be waiting to get input from the different units which are connected to the port. Fine, are you getting me? And in contrast with this, using the programming, if you write value 1 to the port P0, now in this case the port P0 is configured as output port, and your port P0 will be waiting to get the get the data from the microcontroller towards the unit, towards any output unit. Fine. So this is how it works. Fine. So let us go port by port, and then we'll clarify everything, and straight away we'll go to the programming, because programming part is more important in this. One important thing which you need to remember is that when you're using the port P0 of 8051, this is 8051, this is the port P0. See how to write the different bits of port P0. We all know that port P0 consists of 8 bits. Port P0 consists of 8 bits. Fine. So how to write the 8 bits of port P0? We write the 8 bits like port P0.0, this is the first bit, P0.1, that is the second bit, P0.2 till P0.7. Fine. So this is total 8 bits. This is how we write the different bits of all the ports. If you wanted to write the different bits of port 2, we write P2.0 till P2.7. So what it is the different bits of port. We'll see in the programming how to access a single bit also. Fine. So one thing which you need to remember, that when you're using the port 0 either as an input port or as an output port, in that case you have to use some pull-up resistors. These are known as pull-up resistors. I will not go in detail of this, but please remember this, all the CSIT students. I cannot explain this to the mechanical and civil students, because they have never studied the electronic circuits, so I don't think so they will be able to understand this. But they can remember this, that whenever you wanted to use the port P0, whenever you wanted to use only port P0, this is not for port P1, P2 and P3. This is only for the port P0. Whenever you want to use port P0 either as an input port or output port, in that case you have to attach a power supply. This VCC is what? Power supply. And for each bit of port you have to use resistance, and the value of that resistance is 10 kilo ohms. Fine. This is this you should remember. Fine. This might be asked to you, or if you are drawing a diagram for connecting port B0 with any other unit like this, then this connection is very important. Fine. Or otherwise, if you are using any other port like port P2, and if you are connecting these 8 bits of port P2 or any unit, then you can directly connect like this. You do not to do such kind of diagram, such kind of connection. You can directly connect each bit of to a particular unit. Fine. So this is the difference between all the ports and the port P0. Port P0 needs to be connected like this only for those students which understand what is transistor. I would like to explain for a minute that why we are using this 10 kilo ohm resistance. Actually all these ports, all these bits are connected to the MOS transistor. Fine. Like this. The diagram is already there. This is the MOS transistor. Fine. So what happens in a MOS transistor? This is drain, this is source, this is gate. Mechanical civil students and even the ITCS students, please don't get confused. What I am doing, I am explaining why the resistance needs to be connected here. It is not in your syllabus, it is out of your syllabus. Please don't get confused. I'm just explaining for your knowledge. Fine. So what happens at each port, like for example port P0.1, I'm talking about port P0.1, this bit. Port P0.1 is connected to a drain terminal of a MOS. Fine. You have 3 terminals of a MOS: source, gate and drain. So it is connected to drain terminal. So whatever is the information, either the information is 1 or the information is 0, it goes through the drain towards the output. But the drain of a MOS can never be open. The drain of a MOS can never be open. It will not operate. To make it operation, you need to connect this drain to a power supply. Then only a data can be taken from this drain. Fine. So for that purpose you connect a power supply. First you connect a power supply to the port like this. What you are doing, you are connecting a power supply. You connect the power supply to each bits so that these drain terminals are connected to the power supply, but through resistance. You cannot directly connect the power supply. In that case your 8051 will run out. Fine, because it can take excessive current into the port P0. So you connect the resistance which limits the current, and it will make port P0 functional. Fine, so you just remember this thing, because this is core electronics, so you need not to understand that why we are connecting it like this. Fine, just understand this. If you wanted to use port P0, I'm again repeating, if you wanted to use port P0 for reading and writing purpose, for taking data out of 8051 or getting data towards the 8051, if you're using port P0, then you have to connect it like this: power supply and 10 kilo ohm resistance. I think I am now clear here. Fine, so let us go to the next port. Quickly we come to an example, because examples will make it more clear to you. Fine, how to use these ports, let us see. A task has been given to us. The following code will continuously send out to port 0 the alternating value of 55 and AA. Again the same example. The entire book of Mazidi have same examples where the value 55 and AA has been repeatedly used. So I till now I think you might have already cleared that what is 55 and what is A. These are nothing but just values. So these examples, what are these examples doing? They are sending they are changing the value 55 to AA or AA to 55, and then saving them in either of the register, or in this kind of example it will be sending out to port, or it may be getting the data in from the port. Fine, so let us see what they are doing. What is the task? We have to send the data 55 and AA alternatively means first the 55 and then AA and then the 55 and then AA. So alternatively we have to send the data through port 0. I'll again explain. You have 8051 something like this. You have port P0 where the bits are P0.0, P0.1, P0.2 till P0.7. So you have bits like that, P0.0 till P0.7. Fine. So what you have to do, from these 8 bits you have to get out the data from the 8051. What data? First 55 and then some delay. It will remain 55 because this 55 is going to any output device, may get out to any output device, and output device needs some time to display the data. So 55 needs to be remain there for some time. Fine, so you need to give some delay and then convert and then delete this data 55, or this AA would be displaying or getting out from port P0, and then some delay and then again 55. So alternatively you have to get the data from the port P0, which are 55, then some delay, then AA, then some delay, then 55. So how to achieve this using the programming? Let us see how we have achieved this using the programming. What we have done, we have moved the data. First we have taken the data 55, fine, 55 into the accumulator. Then actually what has been done here, we are using port P0. We are using port P0 as output port because we wanted to get we wanted to give data to the port P0. So we are using this in the output mode. Then in that case we have to configure the port P0 in the output mode. We have seen this in the previous slides, that how to configure the port as an output port. To configure the port as an output port, we have to write 0 first. See, we have to configure any port as an output port. We have to write 0 to it. Fine. Otherwise by default they are always input ports. Fine. So in this case what we are doing, we are configuring port P0 as output port. So I think these lines are missing in this program. Fine. So what we have to do, before writing these codes, we have to configure the port P0 as output port, and that is very simple. What you have to do, just move into P0. What we need to move, we just have to move the data 00H. By doing this, what will happen, hash 00H, I'm sorry. So what will happen by doing this, the port P0, by writing this line, the port P0 is configured. It is configured as what, as output port. Now you can use port P0 as output port. So this line needs to be there. Fine. This is missing here in this example, so I have written this line. So this is the first line of our program. Then from the second line, what we'll do, what we have to move, we have to move 55 and AA. So first we'll take 55 into the accumulator and then move the data of the accumulator to the port P0. It's very simple. Just move the data 55 to the port P0 using the move command. We have to just write the move command, that's it. And then 55 is already there on the port P0. Now you have to move AA, but after a delay. Fine. So how to get the delay inside a program, we have covered this in our last lecture. Just call the delay subroutine. It might be written somewhere here. Fine. We have already used these kinds of program in our last lecture. So just call the delay, it will give some delay, and during this delay what will happen, 55 will remain on the port P0 because you have already written P0 55 on port P0. So 55 will remain at port P0. It will remain for some time. How much time? The time for which the delay is there. And in my last lecture I have already taught you how to calculate the time. Fine. So for a particular time you can write 55 on that port P0. Then again move the AA to the accumulator, the value AA to the accumulator, and then move AA to the port P0. Now what will happen, AA, the value AA will start getting out from port P0. Fine. Initially it was 55 for some time and now it is AA. Now I'll again call the delay because I need to remain at the value AA for some time, and then I will jump back to the main line, first line, so that again 55 would be displayed. So this is how from the port P0 the value 55 and AA would be displayed. It's very simple. So you can go through this program once again so that it would be clear to all you. Fine. And please try to make these programs by yourself also, because in our last lecture also I have given the same program, but instead of using the ports we were saving these data in a register. Fine. So what we have done there, this program can be written by n number of ways. For example, one of the way can be I am writing value 55 into the accumulator. Now I am moving this 55 to the port P0. Fine. And then moving the data AA to the accumulator. So instead of doing this, I can use the complement CPL complement instruction. Fine. In the last lecture we have done this. I can complement the accumulator. Now accumulator will become AA. So instead of writing this statement, I can directly write complement. Fine. And then we can move the value of the accumulator into the port P0, and this will be same as this program. This is one of the way of doing this program. Another way of doing this program can be, instead of moving the value of the accumulator into the port, we can directly move the value into the port. Like we wanted to move 55 to port P0, then we can just write move into the port P0 what, 55H. Simple. Hash 55H. So what it will do, it will move 55 into the port P0. So we need not to use accumulator. So please try to do it by yourself, that these programs can be done by n number of ways. Fine. So instead of mugging up the programs, you try to make these programs by your own. So this will be very helpful for you. Now we move forward. See the same thing which I have saying. In order to make port 0 as input, first we have to write 1 to it. Fine. So let us see, this is a second example. Let's see what it is saying. Port 0 is configured first as input port. Fine. So what we have to do, we have to configure port 0 as input port. How to configure port 0 as input port? Just write 1 to it. Please remember, to configure any port port P0, P1, P2, P3 and P4, P0, P1, P2 and P3, if you write 1 to it, it is configured as input port. That means it is now ready to accept input. Fine. If you write 0 to it, then it is configured as output. That means it is now configured as output port, and it will take output from the microcontroller to any other unit. Fine. So please remember this. So what this program is asking, that port P0 is first configured as input port, and then by writing 1, we all know that, and then data is received from that port and set to port P1. Fine. So what this program is doing, it's very simple. This is your microcontroller, you have port P0 here, your port P1 here. So what it will do, you configure your port P0 as input port, configure your port P1 as output port, take the data from port P0 and direct the same data to port P1. Did you get it? It's a very simple program. Configure your port P0 as input port, configure your port P1 as output port. Fine. Take the data from port 0 and send the same data to port P1. Fine. So how to achieve this? This is a very simple program. Then first what we have to do, we have to configure those ports as either input port or output port. So just move the data FF into A and move that value FF into P0. What we are doing here, we are moving 1. What is FF? FF is all 1, 1, 1, 1, 1, 1, 1. So what we are doing, we are moving 1 to port P0. What will happen when we move 1 to port P0? I have already told you, when we move 1 to any port, that particular port will be configured as input port. So now using these two lines, the port is configured as input port. We could have write these two lines by using a single statement like this: move P0 comma hash FFH. We could have done this like also. Instead of two lines, we could have written this with a single line also, but you should know both the ways. So what we have done, we have written FF into the port P0. By using this, what has happened, the port P0 has become an input port. Now our main motto was to get the data into port P0 and get out the data from port P1. So get the data from port P0, move that particular data into the accumulator. Fine. We are getting the data from the port P0, get that data into the accumulator, and getting the data, after getting the data, move that particular data into the port P1. Simple. It's very easy. So one step is actually missing here. Before doing that, we have to make the port P1 as the output port. For making the port P1 as output port, we have to write one more line: move P1 comma 00H hash 00H. By writing this line, what will happen? The port P1 would be configured as output port. Fine. So port P1 is configured as output port and port P0 is configured as input port. From the input port P0, we are getting the data into the accumulator. Since accumulator now contains the data which is coming from P0, so we move that data to the port P1. That's very easy. And then you come back as jump bang. What it will do, you come back and check whether there is a data in the P0. If there is a data, move into the accumulator and move that accumulated data into the P1. So it is just moving data from port 0 P0 to the accumulator and then accumulator to P1. Then it is again checking for any data. If there is a data which is at P0, move that into the accumulator and to the P1. It's very easy program. Fine. Now let us move to the next program. Port P0. See, port P0, we have used this port P0 for getting the data and we have used this port P0 in one of the program to get out the data AA and 55. Fine, we have taken two examples. But this port P0, let us come back to the original IC diagram. This port P0 can be used to get the data out of the microcontroller, or get the data into the microcontroller. We have used both the examples, but this port is also used as address bus. If you can see, AD0, AD1, AD2, AD3, what does it mean? It means AD. AD means address. AD means address. So this port is also used to move the address. This port is also used to move the address out of 8051. Fine. Why we want to move address out of 8051? All you students, please pause the video, or after the video, please try to remember my lectures which I have given in the class, that why we are using address in any microcontroller or any microprocessor. Fine. Now we have already seen that this port P0, this acts as a address carrier also. So sometimes you are moving the data through this port P0, and sometimes you are moving the address also. Fine. So the same port is also used for moving the address. Fine. Moving the address where? Moving the address towards the memory. If you wanted to read something from the memory, the address of that memory location you need to know, and you need to move the address from the microcontroller to the memory. From what bus? You need to have an address bus. So this, in that case, this will act as an address bus, port P0. And remember, address is of 16-bit, but this port P0 is of 8-bit only. So how it can carry the address? In that case, your two different ports will act as a address bus. Which ports? Port P0 and port P2. See, AD0 to AD7. This is what? Lower 8 bits of, these are lower 8 bits of address bus. Lower 8 bits of address bus, because your address bus is of 16-bit. So it is divided into two buses, 8-bit port of port 0 and 8-bit of port 2. See, AD0 to AD7, so this is lower 8 bits, and A8 to A15. A8 to A15. This is address bit 8 to address bit 15. Fine. So by combining this, it is A0 to A15. That is 16-bit address. So using the port P0 and P2, you are moving the address out of the 8051 to the N unit. So entire 16-bit address will be sent from using port P0 and P2 combinedly. Fine. So port P0 and P2 can be used to take data from the input from the units to the controller, and from controller to the units independently, and they are also used to move the addresses. Fine. You need to remember this. Now come back to slide again. So where we were? Yes, we have already done this. We have done this. Now port 2 is also used as an address. We have already seen. But remember, in the port 2, port 1 and port 3, we are not using any pull-up resistor as we have used in the port P0. Please do remember this. One more thing is very important. Go to the IC design again. Port P0 and P2 will combinedly be used as an data exchanging the data, and it will be also used for giving out the address. Fine. The port P1 is only used for exchanging the data between the units. It is used for getting the data and is getting out the data. That's it. Fine. Port P1 has no other use. It is only used for data exchange. But port P3 is used to exchange the data, but it is also used for doing some specific works. As we can see, these RxD, TxD, INT. So they are used for some other specific work also, apart from using as a data port. Fine. So we will see what are the other things that port 3 is doing. Let us go. So this is port P3. These are the various bits of port P3. The first 8 bits are P3.0, P3.1 till P3.7. Fine. So definitely they will be used to move the data. Apart from moving the data, they are also used for some specific purpose. What are those purpose? These first two pins, P30 and P31, they are specifically used for serial communication. In one of my class, in the classroom, I have already explained what is serial communication. Here also I'll try to explain you what is serial communication. What happens using the 8 bits, using the 8-bit ports, what you are doing, you are moving the 8-bit data, using the 8-bit data towards any unit, any output unit. For example, we are trying to move the data towards the monitor. Fine. This is the 8-bit data. What happens if you wanted to move 64-bit data? I'm again repeating my question. What if I have to move the 64-bit data? What will you do? You will move first the 8-bit data, then again the 8-bit data, then again the 8-bit data, then again the 8-bit data. The entire data will go to the monitor. It will be stored at the monitor until the complete 64 data have been achieved. Once the 64-bit data has been achieved, it will be displayed on the monitor. Fine. This is how it works. Fine. This is known as parallel movement of parallel data, because 8 bits are parallelly moved. Fine. But in originality or in practical, it is not like 64-bit data. It is thousands of bits of data, because when you use internet, for example, when you use internet, how you use your internet? You recharge with a pack of 1 GB and 1.5 GB. So what does it mean? It means that for an entire day you are using 2 to the power 10 MB. 2 to the power 10 MB. That is how much? 1024 multiplied by 10 to the power 6 10 to the power 6 bytes. This much amount of bits are transferred from one unit to another unit. If these much amount of bits are transferred, then if you try to transfer it using only 8-bit bus, it would be a very cumbersome task. It cannot be done. So what other technology it is used? It in the electronic devices, what has been used for communication? A single link has been used to move the data from one unit to another unit. How the single link would be used? If the data is of, let us say, 16 bits, then those 16 bits are assembled like this: first bit, second bit, third bit till 16 bit, and bit by bit is moved through that single line, and it is received at the receiver. First bit will go, then second bit, then third bit will go, then fourth bit will go through the same link. So this is known as serial communication. By using this way, you can move any size of data. Fine. Definitely it will take time, because parallel processing is more faster. If you are moving the parallel data, it is more faster, because data can move from this all the 8 bits. But in a single link, all the 8-bit data, first bit will go, then second bit, then fourth bit, fifth bit, and then the 8-bit. So definitely it will take time, but serial communication is far better than parallel communication, because if you wanted to move thousands of bits, you cannot have thousands of lines. That is impractical. Fine. So you use serial communication. So for using serial communication or doing serial communication using 8051, we use 2 pins of port P3, that is RxD and TxD. RxD means receiving, it is receiving the data, and TxD means it is transmitting the data. So what it is doing, the port P3.0 is used to receive the serial data into the 8051, and port P3.1 is used to transmit the serial data to any other unit. Fine. I think this is clear to you all. Now the other 2 bits, port P3.2 and port P3.3. They are used as the interrupt input. Fine. So we will cover this interrupt portion in our third unit, but I'll quickly explain it to you that if I am making a video and I'm giving a video lecture, and if anybody comes to me and disturbs me, then I have to pause this video. So that is an interrupt for me. We all know what interrupt means. So the similar kind of way the 8051 works. When 8051 is executing something, it is executing a program, and if any interrupt comes, for example there is a hardware failure, there is a power failure, or you press some keys on the keyboard, that is an interrupt for 8051. Fine. So to get the interrupt from the output units or from the other units to the 8051, you have two inputs, that is interrupt 0 and interrupt 1. So there are two pins from which interrupt can go into the 8051. We'll cover what are interrupts into the unit 3. Then I've already told you 8051 has two timers. Fine. 8051 has two timers to maintain the timing, or to just simply remember it like this. The timer, why the 8051 has timer? It has timer to count something. For example, it has to count till 10 and then do something, then it has to count till 50 and then do something. So how it will count? It doesn't have a clock of its own. So how it will do? It will make use of that counter. Fine. Since it has two counters, so for those two counters you have two pins, T0 and T1. T0 is for timer 0 and T1 is for timer 1. Fine. Now we all know how much memory does 8051 has. You should know this. 8051 has 128 bytes of RAM. And how much ROM does it have? Onboard ROM. Please try to answer it by yourself. I will not answer this in this video lecture. Please try to answer it by yourself, because in our previous lectures, or in our lecture 1, lecture 2, lecture 3 in the classroom, I've already told you all these things, that how much memory ROM does 8051 has, onboard ROM or on chip ROM. Fine. So it has only a limited, I will not tell you how much ROM it has, but it has a limited amount of ROM on the chip. But what if you wanted to write a large program? Because programs are saved in ROM itself. If you wanted to write a large program, in that case you have to attach an external memory to 8051. This is a 8051, you have to attach an external memory. Fine. Similarly, this is similar to that. You attach a external card to your mobile phones. Fine. So this is similar to that. If 8051 wanted to have a large memory for program, external memory has to be attached to it. Fine. How the external memory or 8051 will communicate to external memory? For example, 8051 wanted to write something into the external memory. How it will do? It has two pins. Those are P3.6 and P3.7. The pins of port P3. Last two pins of port P3, which are write bar and read bar. What does it mean? If 8051 wanted to write something into the external memory, it will first give the signal write bar. The write bar signal is connected between 8051 and the external memory. The write bar is enabled. That means the microcontroller is trying to write something into the external memory. Fine. And if read bar is also connected between 8051 and the external memory. So if the read bar is enabled, that means the 8051 is wanted to read a particular memory location. Fine. So these two pins are using as a control pins for reading and writing the external memory. That's it. This is what you have to remember. Fine. So let us move to the new section. A program will make it more easier to you to understand how to do the ports programming. Fine. This is a good program. What it is doing, just leave this. What it is, just leave this. What it is doing, it is toggling the bits. It is toggling the bits of port P0, P1 and P2. All the three ports P0, P1 and P2. every 1 by 4 second. So what it is doing, it is toggling the bits. Toggling means, it is just complementing what we were doing in our last program, converting 55 to AA, that is complement. And toggling means whatever is the value of port P0, whatever is the value of port P0, either FF or 00 or 55, whatever its value, you just toggle it. Toggle means complement it. Fine. If it is FF, it becomes 00. If it is 55, it will become AA. I will already explain these things, complement operation, in my last video lectures. So what you have to do, you just have to complement the values of all these three ports, P0, P1 and P2. Whatever these ports contains, you have to complement their value after every 1 by 4 second. So after every 0.25 second, you have to toggle them. Fine. How to do this? Let us see. This is how we start the program. org0. Sometimes it is written in the book, sometimes it is not written in the book. So but practically whenever we are writing the program to 8051, we should give this assembler directive. This is known as assembler directive, that where we are writing the program inside the ROM. So at the first location, which is 000, we are writing from here. We could have written from here also, from here also. So we have to direct the 8051, that from where we are writing the program in the ROM. So it is where we are writing from the first location. So OR0 means from the first location in the ROM we are starting writing the program first. So again they have used the 55 and AA. See, so they have taken 50. What I have told, that if there is any value in the port P0, it should be toggled. So instead of using any random value, they are using 55. So first move 55 into the accumulator, then move that 55 into port P0, into port P1, into port P2. So we are using three ports, port P0, P1 and P2. What we have done, we have moved the value 55 to all these ports, and then what we will do, we will toggle them. Fine. So before toggling, what we have to do, we have to call a delay, because 55 should remain there. This 55 is written to all these ports, port P1, P2 and P0. So 55 should remain there. So to maintain, and for how much time it should remain? It should remain for 1 by 4 second. Exactly. After 1 by 4 second, it should toggle. So complement of 55 is AA, so it should complement. So what we have done, we have called a delay. We will see that delay. What is that delay? That is exactly making a delay of 1 by 4 second. How it is making, we'll see. We have called the delay. Once after 55, there's a delay of 1 by 4 second. We have called the delay. How it is made, we will see. And then coming back from the subroutine, it is moving the value AA, because the complement of 55 is AA. So instead of moving the AA, we could have written this line. We could have written this line CPL. CPL means complement A. What it has done, what it will do, it will make 55 to AA. So instead of moving AA into A, we could have done the complement. Or this is also okay, because we are not using the instruction complement here. So what they have done, they have moved the value AA. They have moved the value AA into accumulator, and that value AA to each of the port. Fine. And then again call the delay. So what this delay will do, 55 has been made to AA after 1 by 4 second. Then after again 1 by 4 second, it will made to 55. This is that program is doing. Now let us see how it is making a delay of 1 by 4 second. In my last video lecture, I have already explained how to get a specific delay, or how to calculate the delay of a subroutine. So this is what that is done here. They have used a nested loop. They have used 3 resistors, and 3 resistors are loaded with some values. Fine. So these are not random values, these are pre-calculated values. Fine. For getting a delay of 1 by 4 second, that is nothing but 0.25 second, you have to remember, there's no other way that you can exactly design 1 by 4 second. You have to do hit and trial, for you students, you can do the hit and trial, but in your exams you cannot do the hit and trial, because hit and trial takes some times. So you have to remember that if making 1 by 4 second, what you have to do, you have to take three values: 11, 248 and 255. Fine. 11, 248 and 255, and make three loops. When you make loop inside a loop, that is known as nested loops. I have already explained in the video lecture where I was explaining you the jump loop and call instructions. Fine. So this is loop inside a loop. So by using loop inside a loop, you are able to exactly make a delay of 0.25 seconds. How? 248 multiplied by 255 multiplied by 11. So this is loop inside a loop. Fine. So 11 multiplied by 248 multiplied by 255, and each of this I'm sorry, the entire subroutine is using 4 machine cycles. So it is multiplied by the 4, and that is multiplied by the 90 nanosecond, because 90 nanosecond is a specific for this microcontroller. If it would have been 8051, please tell me how much we would have multiplied here. We would have multiplied 0.805. How you can remember? I actually remember during my undergraduate, during my BTech, 8051 is the microcontroller, so exactly 0.805 is the 0.805 microsecond is the clock period of this. Fine. This is how I remember during my BTech. So you need not to remember, because this kind of questions would not be asked to you. So instead of multiplying 90 nanosecond, if this is 8051, then you would have written, I'm sorry, it is not 0.85, it is 1.850 microsecond. Fine. You have to write 1.805 here if this was 8051, but this is not 8051, this is this processor, and for this processor the clock period is 90 nanosecond. So you have multiplied 90 nanosecond. What I am doing here, this I have already explained in my last video lecture, so I am not explaining it here. You just have to multiply the values of these resistors with the machine cycle which is taken by the subroutine with the value of single clock period. The value of single clock period is here as 90 nanosecond. So it is calculated as 250 microseconds. Fine. And 250 microsecond is exactly 0.25. So this is how you are able to generate a delay of 1 by 4 seconds. Fine. So this was a good example. The same program has been written again in an efficient manner. They are saying that we are writing the program in an efficient manner. What they are doing, they are moving the value into the P1, calling the delay, and then moving the value in the P1, and then again calling the delay and using jump. This we have already done. Fine. This is not a new thing. Next, what they are doing? Okay, so they are writing that we could efficiently done this program using the complement instruction. I have already told you. You can also write on complement instructions. Fine. This is important. What happens? Those all ports are of 8 bits. So by using these kind of programs, what we are doing, we are directly accessing all the 8 bits of the port. Fine. For example, if you are writing this move P1 comma A, what does it mean? It means that all the 8 bits of accumulator, bit 0, bit 1, bit 2 till bit 7, all the 8 bits of accumulator are moved to the corresponding 8 bits of port P1, I'm sorry. Fine. P1.0, P1.1 till P1.7. So all the 8 bits of accumulator are moved to the 8 bits of port P1. But what if we wanted to move only a single bit? What we wanted to get only a single bit from a port? In that case, we have to do a bit programming. How to do bit programming? It's also very easy. See, if for example, what is the question? Yes, if you wanted to toggle only the second bit of P1, then what you do, you just complement the second bit. Instead of complementing the entire value, you just complement the second bit. That's it. You just complement with the second bit. Instead of complementing the entire accumulator or entire value, just complement it with the second bit. Fine. So whatever is the value of the second bit, for example it was 0, now it will become 1. If it would have been 1, it will become 0. So your value has been toggled, so you can directly access the single bit also. Fine. Another variation of the same program. Fine. Now this is an important program. You just try to understand this program. This is very important as far as your exam is also concerned. Write a program. What it is doing, write a program to generate a 50% duty cycle of bit 0 of port 1. What we have to do, this is a port 1 consisting of 8 bits. So from the first bit of port 1, you need to generate a square wave like this. Fine. So what is this square wave? Square wave is nothing but value 1 0 1 0. So this is just toggling the value of this bit 1 0 1 0. But it should be remembered that the duration of 1 should be equal to the duration of this 0. This is what 50% duty cycle means. Fine. So you just remember what is duty cycle, because I will not go deep into this. I think mechanical guys would be knowing what is the duty cycle of the motor. Fine. So duty cycle of motor is the on time upon on time plus off time, and 50% duty cycle means off time is equal to on time. Fine. So what 50% duty cycle means? 50% duty cycle means the value 1 and the value 0 should be of same length. Fine. This is very easy. So how to achieve this? How to do the single bit programming of port 1? That is important. Fine. How we have done that? Let's see. First, just set the value of port P10. So the first bit is set B. Set B means set the bit. So port P1.0. The diagram has already been there. Yes. So what you have done? First, set the bit. Set the bit means set the bit. Set bit means your this bit will become 1. Fine. 1 means high, like this. So this bit became high. This bit became high, and once this became high, you call some delay, because this high has been made here, and if you again make it 0, it will become like this. So your purpose is not achieved. Your purpose is to make it 1 for some time and 0 for some time. So you need to call a delay subroutine. So you have called a delay subroutine here. What is that delay subroutine? We already know what is delay subroutine. Fine. So you call the delay subroutine and then come back from that delay. So till that time the P1.0 will be having 1, and when you come back from the subroutine, you clear the P1.0. What is clear? Clear means whatever is the value of that bit, it will become 0. Clear means it will become 0. So now P1.0 became 0, but 0 should remain for some time. So we again call delay, and for that particular amount of delay it will remain 0, and then we will jump again to the same thing where it will become 1. So it has become 1. It will remain there 1 for some time. So we again have to call the delay. Then we have to again make 0. So we will clear it and then call delay. So it will remain 0 for some time. So this is how it will continue to happen using this loop. Fine. So this is a very good program, and you should go through this program, so that you will get to know that how to do the programming of single bit also. So instead of using the entire port, you can use a single bit of that port also. Fine. This is one more way how it is done. Again, I have already told you, you can complement the value. If you wanted to toggle the value, you can move the new value also, or you can complement the value also. So there they have complemented it, because you have to toggle the value 1 to 0. Fine. So 1 to 0 means just either you set it or clear it. Clear means making the value 0, set means making the value 1. Either you can set it or clear it, or you can just make the complement, because complement is making 1 to 0 and 0 to 1. Fine. So you can directly make it complement also. Fine. These are the various bit instruction you can use for your bit programming. Fine. There's one more program. This is also a good program. Write a program. Please try to understand this program. This would be our last program of this video, and this slide consists of 3 or 4 more examples. So I'll leave these examples to you. Please analyze those examples, read those examples, so that you can get a flavor of how the bit programming is done using the ports. Fine. So let us see what is this. Write a program to perform the following. Keep monitoring the bit p1.2. So the port p1, you have 8-bit port. Only the second bit of this port, we have to monitor that port. Monitor means keep watching that port until it becomes high. So what microcontroller has to do? It has to do nothing. It has to just look at the bit 2 of port 1. Keep looking at bit 2 of port 1, that whenever it is high, that means whenever 1 comes to this port, whenever 1 comes to this port, whenever it is high, write value 45 to port 0. So value 45 would be stored somewhere in the registers of 8051. It will be moved to port P0. Fine. And send a high to low pulse to port P2.3. So you have port P2, the third bit of P2 port.3 P2 will be the output from third bit would be something like that, high to low pulse, high to low pulse. So a pulse something like this will go from this. I'll again explain what this program wants to do. I'll again explain to you. The 8051 should keep on watching the second bit of port P1. It will do nothing. It will keep on watching. Whenever it becomes high, high means getting 1. Whenever 1 is received at port P1, not port P1, the second bit of port P1, what will happen? The 45H, which is stored inside the 8051, will move to the port P0. Fine. 45H will move to the port P0. When it will move? It will move only when 1 is received at port P1. So you have to move the high to low pulse from P2.3. Fine. Now how to do this? You have already seen in the last example how to move the pulse out of any port. Fine. So just set the bit P1.2. Why we have done this? Why we have set the bit P1.2? Setting a bit means make its value 1. Why we have done this? Because if we wanted to use the port P1 as input port, then we have to first make its value 1. Fine. So using this port P1.2 as input port, we have just first send 1 to it. Fine. Now it is used as a port. It is used as a input port. Now store a value 45 into the accumulator, because it would be used further in our program. Fine. Because we have to write 45 to port 0, so 45 is already stored at accumulator. Then look at this line, jump if bit is not set. JNB means jump if bit is not set. So we keep on monitoring the bit P1.2. This is the requirement of our program, that we should keep on checking the value P1.2. If it is not set, If it is not set means if 1 doesn't comes to it. Fine, we are keep on checking the p1.2 that whether a 1 comes to it or not. How to check it? Just write JNB. JNB means whether the bit is set or not. Fine. So p1.2, what is the value of p1.2? Although we have already set it here, some student might confuse that we have already set it here. No, we are not giving the value 1 to p1.2. What we are doing, we are making it as input port. Fine. So after making it as input port, the p1.2 is empty, it has no value, so it is waiting for any value to come. A 1 could also come, a 0 could also come, so we wanted a 1 here. Fine. So we could keep on checking by using this instruction jump if bit is not set. Fine. Whenever p1.2 is 0, it is not set, that means please jump to again, and where is again? Again is here itself, so it will keep on jumping the same line. Fine. So initially also I have told you in this program that we need to monitor the same pin. We keep on monitoring the same pin. What is that pin? p1.2. The 8051 will not do nothing, it will keep on monitoring. So how to monitor? I'll write an instruction jump if bit is not set. That means until the bit is not set, please be here itself. Jump to again, where is again? Again is here, so please be here itself. Do not go anywhere, don't do anything, just keep on monitoring the pin p1.2. Whenever the bit is set, then it will not go to again, it will go to the next instruction. Fine. So let us say 1 comes here. Whenever 1 comes here, it will go to the next instruction. What is the next instruction? Our next task was moving 45 to port 0, so we have done it. Move the 45, A contains the 45, so move 45 to port P0. Then it was told that send a high to low pulse to P2.3. What is high to low pulse? This is high to low pulse. Set P2.3, set P2.3 means 1, and then clear P2.3 means 0. So this is a high to low pulse. So simply you just have to set the bit P2.3, set means make it 1, it will become high, and clear P2.3, that means it will become low. So this is nothing but high to low pulse. From what port? From port bit P2.3. So your program is done. You see, your program looked complex, your question looked like a complex that how we will do this, but it's done only within 4 lines. Fine. How easy it is. So just try to do it by yourself also, so that you can understand. And apart from this, we have some interesting examples also. I will not cover this in this lecture because this is very easy. So you try to cover, try to do by yourself, because solution is already given there. For example, this is a good question where it is used for a I think it is used for a oven. Yes, it is used for oven, that a single bit of oven is kept on checking whether it is hot or not. When it becomes hot, it will turn on a buzzer. Fine. So it is similar to the last example, but instead of you just moving the bits from one port to another port, it is using statements like oven, buzzer. So students might confused how to use buzzer, how to use oven. It is nothing but the port p1.5, p2.3. so you just read this and you'll get to know. It's very easy. Fine. It's just 4-line program. Fine. So this is one example. There's one more example, I think. Yes, there is one more example. This is also very good example. Here what you are doing, you are checking a particular port. You are checking a particular port. On that port you are having a switch. For example, you are checking a port, checking a bit this, and this bit is having a switch. This bit is having a switch, on off switch. So whenever you push it, a signal will go into this. For example, a 1 will go into this. So you just have to check 1 here through programming. You need not to do any switching. You just have to check 1. You have already done that thing in the last program, so no new thing has to be done. You just have to check this. How to check? See, jump if bit is set, JB. So what it is doing, it is just checking whether it is 1 or not. Fine. So a switch is there, you just have to check whether the switch is on or not. On means it is 1 or not, and you have to check 0 also, whether it is off or not. Whenever it is off, you need to send a letter N to particular port, otherwise you need to send a letter Y to another port. Why this is important? Because this is covering this Y or N. We have never moved any letter through any port. We have moved only the digits or the bits. It is very easy to move the bits, fine, but how to move the letter? For moving the letter through a port, how to write it? Move p2 comma hash and then n within the inverted commas. Why not inverted commas? Inverted commas means because computer 8051 or any microprocessor doesn't understand what is ABCD. It only understands the digits. So n within the inverted commas means it is the ASCII value. I think in one of my video lecture only I have explained what are ASCII values, so you can go through that. So how to move letters, how to move English letters, fine. So here we have moved n, or whoever who doesn't want to go deep into this programming, just look at this. Instead of moving the value like we were moving value 55 like this, so instead of doing writing like this, if we are trying to move English letters, we have taken inverted commas. That's it, no other difference, fine. And if somebody wants to understand what is ASCII value, they can go to my video lecture which I have already told what is ASCII, fine. And this example similar to this example, last example, but done in a different way using carry flag. So I recommend you all students should go through this program. This is also very important program as far as your semester exams are concerned, fine. So only this till 7th example, you have to cover only till 7th example, fine. So your second unit is finished here, and the important things which you need to study in your second unit, the question bank which I have given to you, that will cover the theoretical questions and the conceptual questions, and these slides which I am sharing to you, whatever programs are covered in these slides by me, all those programs are important and that could be asked in your semester exam. So please get prepared, be prepared, fine. So thank you, and that's it for this lecture.